Number 17. For the cost and price function below, find the number Q of units that produces the maximum profit, the price P per unit that produces the maximum profit, and C, the maximum profit. So it's important to remember here that profit equals revenue minus cost, and revenue equals price times quantity. So we know the cost function and we know the price, but we don't know the revenue function. So R of X is price, 71 minus 2Q, times Q, or 71Q minus 2Q squared. So you have to remember to multiply this price here by Q, the quantity. All right? So now we know that our profit is this revenue, R of X, minus C of X. So it's going to be 71Q minus 2Q squared minus, and be careful, here's where a lot of issues come in, the entire cost function. So in other words, I have to minus both of those terms. So it's going to be 71Q minus 2Q squared minus 90 minus 19Q. So we do have some Q terms that can be combined. I've got a 71 minus a 19. So that's going to give me negative 2Q squared plus 52Q minus 90. Now that is the equation for the profit. We want to find the maximum of this profit. So we need to find the derivative. So P prime of Q this time, not of X, but of Q, is negative 4Q plus 52. Negative 4Q plus 52 equals 0. Negative 4Q equals negative 52. Q equals negative 52 divided by negative 4. So Q is 13. So our quantity is 13. So that should be a maximum. But before we declare that to be a maximum, let's make sure that the derivative changes from positive to negative, indicating an increasing function, and then a decreasing, which would be a maximum. So we'll take our derivative, negative 4Q plus 52. Here's 13, where it's actually 0. So check a point to the left, negative 4Q plus 52 is going to be positive over here, because if you put a 0 here, you're going to get 52. And if you put something bigger than 13, say I put a 20, that's going to be negative 4 times 20. That's going to be a negative 80 plus 52. So it's going to be minus here. So the original function was climbing and then falling. So yes, you've got a maximum there. So the number of units that produce the maximum is 13 units. Now let's make sure it's not in hundreds or something. It's not, so the answer is just 13. Now the price is what happens when you put 13 into the price formula. So our price is going to be 71 minus 2 times 13, or 71 minus 26. So 71 minus 26, 45. So our price is 45 and we'll assume it's $45. They give us a dollar sign, so $45. Now, what is our maximum profit? Well, if the number of units we need to produce is 13, what we need to do now is put 13 into the profit function. So let's go back up here. Your profit function is this function right here. Remember where we subtracted the cost from the revenue? So let's take this profit function and go down here and evaluate it at 13. So profit at 13 is negative 2 times 13 squared plus 52 times 13 minus 90. So that's going to be negative 2 times 169 plus 52 times 13, 676, minus 90. So let's see, 169 times negative 2 is going to be negative 338 plus 676 minus 90. So negative 338 plus 676 minus 90 is our maximum profit, $248. Now that may not sound like a lot, but in regular or normal production, you might be dealing with 13 million units of the product, or 13 times 100,000. So all of this would get multiplied by 1,000 or 10,000 or even 100,000 or even more.